Good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about the effect of parasitic inductance. This topic comes under the high frequency design complexity and PCB design, fourth unit of W band gap, wide band gap devices. Come, let's get into the topic. So, electric inductance is a property of all conductors. A change in the current flowing through a conductor that induces, that means created means induces a voltage in the conductor as well as the nearby conductors. The induced voltage opposes the change in the current that induced the voltage. Induced is a consequence of two laws of physics. Firstly, a constant current flowing through a conductor creates a constant magnetic field. Secondly, a variable magnetic field induces the voltage in all the nearby conductors. The conductor which was used to create the magnetic field is the first place. So when these two laws are combined, the resulting effect in the inductance, just like resistors are used to introduce desired resistance in the circuit, like capacitors are used to introduce a desired capacitance. Inductors are electrical elements to use to introduce the desired amount of inductance into the circuit. The inductance formula for an ideal solenoid means a coil of wire wound around a cylindrical body of a metal is given by L equal to nu n square A by L, where L is the inductance, mu is the magnetic permeability of the material used in the inductor. Yeah, A is the cross-sectional area of the coil, and L is the length of the solenoid. That is not the length of the wire, but the longitude dimension of the coil. So here, this is the ideal capacitor is shown here. We usually draw like this ideal capacitor. So here, this is the to I mean to make the people to understand the parasitic inductance. So simplified model of real capacitor is shown over here. The ideal capacitor has no resistance and no inductance, but has a defined and constant value of capacitance. The unit used to represent inductance is Henry, named after Joseph Henry, an American scientist who discovered inductance. Parasitic inductance is an unwanted inductance effect that is unavoidably present in all the real electronic devices. As opposed to deliberate inductance, which is introduced into the circuit by the use of inductor, parasitic inductance is almost always an undesired effect. There are few applications in which parasitic inductance is actually a desired effect, such as helical resonators, which can be used as a filters, just like all other real elements used in the electronics, such as the resistors or even connecting wires, capacitors exhibit this effect as well. Parasitic capacitance effect is prominent in high frequency boards when traces are closely placed. This effect is completely unwanted and affects the functionality of the device. It leads to problems like crosstalk, EMI, and signal integrity. So, effect of parasitic capacitance that is shown in this figure. Parasitic capacitance or stray capacitance is the result of virtual capacitor formed between two traces separated by the dielectric. So how the parasitic capacitance is calculated? So from this graphical representation, charging discharging cycle in a capacitor is shown over here. So this is time period, and the y is the current. So the charging is denoted by the color green, and discharging is denoted by the color red. So this is charging and discharging. Parasitic capacitance is an inherent property of the conductor. It is the storage of per unit change in the electric potential. The parasitic capacitance is calculated as C equal to Q by V, where C is the capacitance in farad, V is the voltage in volt, Q is the charge in the coulomb. Trace capacitance calculation. So here this is it is considered as trace 1 and trace 2. The distance between these two is small letter, and the height of the trace is mentioned by h, small letter h. So finally we can calculate C equal to some value by D picofarad. So where A is the area of trace and D is the gap between traces in millimeter, ER is the dielectric constant relevant to air. What is parasitic capacitance? So here this is so that element is shown in this diagram. This is a PCB trace modeling at high frequency. So parasitic elements is present over here. The parasitic capacitance effect is a matter of concern in high frequency circuit boards. While operating at low frequency, parasitic elements can be ignored since they do not have really impact system functionality. Every pad in a circuit board has its parasitic capacitance and every trace has parasitic inductance. So this diagram shows that stray inductance results in a low level oscillations at the op amp output. Thank you.